Okay guys, I just want to do a real quick video, just a wrap up of geometric mean, what we talked about in class. Remember that I talked about this is something that is just kind of an odd thing, and it's better just to know the formula for our purposes. So if you're finding the geometric mean, remember that the formula is x, which is the geometric mean, is equal to the square root of the two numbers you're trying to find the geometric mean of. So x is equal to the square root of a times b. So if you're trying to find the geometric mean of 4 and 9, that means the geometric mean is equal to the square root of 4 times 9. And we know that the square root of 4 is 2, the square root of 9 is 3, so that would be equal to 6. If you're trying to find the geometric mean between 2 and 10, that means that the geometric mean is equal to the square root of 2 times 10, which is the square root of 20. And from the radical video, you know that that's the square root of 4 times 5. The square root of 4 is 2, so it's 2 times the square root of 5. Okay, so all you're going to do is you're going to take the square root of the two numbers multiplied together. Alright, so let's talk about application. So if you have a right triangle, right, so here's my right triangle, it's this original one right here. Okay, the theorem says that if you have a right triangle and from the right angle you draw an altitude that intersects the hypotenuse at another right angle, you split that into 3 similar triangles. So the first theorem we're going to talk about is the altitude theorem. So if you want to solve for the altitude, basically what happens is that the altitude is equal to the geometric mean of these two sides that it creates. So in this instance, when it intersected the hypotenuse, it created a segment that was 4 here and 9 here. So to solve for x, you know that x is equal to the geometric mean of 4 and 9, so 4 times 9, and we know the square root of 4 is 2. Sorry, this should be a 9. We know the square root of 4 is 2, the square root of 9 is 3, so it's equal to 6. Okay, you could also do it where you didn't know that number, so let's say this was 6, we'll just work backwards, and this was 4, and this was x. Okay, so basically you're saying that the altitude, 6, is equal to the geometric mean of 4 and x. So that is the square root of 4 times x. So remember, when you want to get rid of the radical, you're going to square both sides, so 6 squared and the square root of 4x squared. 6 squared is 36 equals 4x squared is the same thing as 4x, and you divide each side by 4, and we get x is equal to 9. Okay, so that's the altitude theorem. The altitude of the triangle is equivalent to the geometric mean of both segments that it creates. Okay, so here's the second one. This one is called the leg theorem. We still have our same right triangle that we start out with. Okay, so we still have that, and then it still has an altitude that's being drawn that intersects at the hypotenuse. Okay, the only difference is that this one is talking about a leg, so it's going to give you, or you're looking for the leg of that big right triangle, and let's say we've got these 3 numbers, so let's say we've got this length is 4, this length is 6. So this one says that the leg of the right triangle is equal to the geometric mean of the leg that's adjacent, so that means you have to use this side, and this is the adjacent side. It's equivalent to the leg that is adjacent and the total hypotenuse. So that means that x is equal to the geometric mean of 4 times 4 plus 6, which is 10. We know that the square root of 4 is 2, so 2 times the square root of 10. Okay, so let's do another example. And this one we'll do it different. We'll do it on this side. So here's x. Let's say this is 3. Actually, let's do this one differently. Let's say that, no, yeah, let's do that. So this is 3, and the entire distance is, let's say, 9. Okay, so we know that the geometric mean, the value of x is equal to the geometric mean of the adjacent side, and we know if this total length is 9 and this one's 3, then this one has to be 6. So it's the geometric mean of the leg that is adjacent and the total hypotenuse, which is 9. So we know the square root of 9 is 3, and we keep the square root of 6 like that. So it would be 3 times the square root of 6. Okay, so really all you guys need to remember is that the theorems stay the same. Okay, so we'll just do it real quick, another just quick review. So right triangle, okay, big right triangle, and altitude is drawn, okay, and it intersects over here, so we've got side A and side B, okay, and the altitude is x, so x is equal to the geometric mean of A times B. Okay, that's one example. The second one we're doing is we have the same right triangle. Okay, there's the right triangle. Altitude is drawn. Still separates A and B, but now we're looking for the leg of the right triangle. So x is equal to the geometric mean of the adjacent side. Right, so here's the adjacent side is A, and the entire hypotenuse. So in this case, the entire hypotenuse would be A plus B. And when you have numbers, you would just add those together. Okay, but these are just your formulas. Just watch this video again if you need some help, and we will talk about it in class. All right, guys, have a good night. Bye-bye.